Good morning. This is your stats sensei, Mr. Spensei, here to talk to you about some scatter plots, and we're actually beginning the last unit we have in our course. So previously we talked about how our course was divided into four major sections. We said we're going to collect data, we're going to display and describe data, we're going to figure the probability of obtaining that type of data, and then we're going to learn how to make inferences based on the likelihood of the results we obtained. Well, one of the things we avoid talking about was bivariate data. And bivariate data means we have a relationship between an X and a Y. Now, previously, we graphed data. Our X-axis list of possible outcomes, and our Y-axis kept track of the counts. That's what we previously were working with. So X listed all possible outcomes, and Y listed the number of counts, or the number of times that outcome occurred. What we're moving into is bivariate, and bivariate does not keep track of counts. Right? Instead, bivariate provides the distinct measurements of a response variable Y for a given value of an explanatory variable X. Since this starts to sound like algebra, it's very much related to that. So once again, our explanatory variable is X, and it's the variable that drives the relationship. In other words, it's our basic inputs, just like we talked about. You talked about when you were in Algebra 1. And our response variable is the Y, and the variable which is the result of a change in the X variable. But with what we're working with, in regression and bivariate data, we believe that there is a relationship between those variables. So the plotting of multiple responses on a scatter plot allows us to determine what type of relationship exists between two variables. And we are able to determine how strong a relationship and how predictive a pattern may be. Scatter plots allow us to see the strength or lack thereof of the relationship. And we also talk about the association between two variables. They also allow us to see patterns and unusual features, such as clusters, gaps, outliers, and points of influence. I'd make sure that I reviewed that. That looks like some things that are kind of important. So here we have the scatter plot, and we'll notice on the x-axis, we have the age of the husband, and on the y-axis, we have the age of the wife. And we notice that in general, the older the husband got, the older the husband is, the older the wife is. And that makes sense. Now, it's not a perfect relationship. If it were a perfect relationship, every single point would lie on a straight line. And I just kind of drew a line of where I thought it might be. You could argue with it. Maybe we should have a little less slope. I also included some ages of some important people here. At the time of his election, this was the age of Donald Trump and Melania Trump. And you can see that they're way below the line. So Donald Trump married someone substantially younger than he is. And this right here is Joe and Jill Biden, all right? And once again, you kind of see where they fall, and they definitely fall below the line as well, having both presidents having married someone substantially younger than they are. Again, we can look at this and go, you know what? We can make some sort of a prediction. We can say, hey, if the older the guy is, we would expect the older the woman is. But it's not perfect, because not every single point lies on the line. But we do see a general trend. And sometimes we see the wife is much older than the guy. But that's just the way this worked out. We can generally have it that the older the husband, the older the wife tends to be. So we're going to go about creating scatter plots, and we're going to use a different set of data. And you probably need to take a moment and enter all this data in L1 and L2. I've already done that. So if I go to my stat edit, you can see that I have 568, 933, all these entered into L1. And then I have the airfare entered in L2. And what we're working on in this case is flying airfares from Atlanta, and we have a distance in miles, and then we have a airfare in dollars. Now, once you have that data in, you probably want to do a real quick check to make sure you don't have a data entry error, because it's a lot of data. So if you go to stat calc, one variable stats, and you go second one, I can sit there and go, okay, I have 853.7, and I have 497.8. So that means I've got the data for my distance in the right location. I don't have a data entry error. And I'll do the same thing for my second list, the airfare in L2. And I have 244.33 and 56.37. So I have my data in there. Well, now that we have our data in there, we're going to go ahead and create a stat plot. For the first thing I'm going to do is I'm going to go to y equals, make sure I don't have anything in there. Fortunately, I don't. I'm going to go to second stat plot. And the only one that I want on is L1. All right. I'm going to press enter, arrow to the left to make sure it's on. And we're going to select the very first graph. And that is our scatter plot graph. And then we're going to drop down, and my X list is in L1, and my Y list is in L2. And I should be able to press zoom 9. And I end up getting a scatter plot of the airfare and distance. And this is what it would look like right there. All right. So that created the scatter plot. And I'll go ahead and go through those calculator commands one more time. So I've entered the data into stat edit. So take a moment and do that. Then I'm going to go to y equals, make sure it's cleared out. Second stat plot, I only want the first graph on. Press enter, arrow to the left, drop down, and I want the very, very first graph. Press enter. My X list, second one, which is my distance, and my Y list, my airfare, second two. Then I press zoom and number 9. So we end up getting something that looks about like that. And if I were just looking at that, I'd go, you know what? If I were trying to go, you know what would be a good predictive line? I would probably draw something like that, maybe a little bit lower. Maybe you come up with a line that looks more like that. But anyway, these are kind of our predictive lines somewhere in there. And what we see is, in general, there is a trend. Now, it's not nearly as close a trend as the age was, but we see that as distance increases, the airfare increase. And since both are increasing, we would say we have a positive relationship because both are increasing. We have a positive slope, just like we had the same thing when we were looking at the age of the wife versus age of the wife versus age of the husband. All right, so now we've created that. And we're going to go ahead, and while we're here, we're going to go, you know what? We actually have a mechanical way of actually creating the line of best fit. All right, and we will cover this in the next video. Be a very, very short video, but in the next video, if you hang on, we will talk about linear regression and the line of best fit. And I'll see you in the next one. Thank you.